In this lesson, we're going to take a look at the structure of an atom. We're going to see how it's put together, what it's made out of, and why it's true when we divide an atom in half, we no longer have the same element. So let's start by looking at elements and atoms. We know this definition. Elements are anything that's made up of only one type of atom, which means there's different types of atoms, and we're going to have to look to see how they're put together. And we know an atom is the smallest part of an element, and therefore changing the atom changes the element. That's why when you cut an atom in half, we don't have the same element we used to have. So cutting gold in half, if we cut gold bars in half, we have two halves of a gold bar. If we cut a gold atom in half, we don't have gold anymore. And we're going to use the periodic table to figure out what all the elements are, how many there are, and what the atoms are that make them up and how they're put together. There's 118 atoms on the table, 118 different elements. 90 are naturally occurring, the rest of them are made in a lab. So let's get started by looking at the parts of an atom. This is probably mostly review. Now this picture down here shows us the overall layout of the atom. It's very not to scale. These little guys out here are electrons. Electrons have negative charges. In reality, they would not be on the same monitor as the nucleus. The nucleus is this clump of things here. Those are protons and neutrons. They make up the nucleus. But this is the right general layout with the nucleus in the middle and the electrons in energy levels. That's these rings things, these energy levels around the outside. So let's start by looking at the nucleus. That's the inner part. So protons are probably the most important part of the atom because they're actually what drives the whole thing. Protons attract electrons and the electrons give us properties. So because we have protons, we have electrons, so the protons make up the atoms and determines what the atom is. They have a positive charge and they're located in the nucleus. So on this picture, it's these little green yellowy guys that have the pluses on them. Those represent protons. They determine the identity and help determine the mass of an atom. When I say identity, I mean which element. Okay? So if I know the number of protons, I also know which element I have. This number of protons is important. It has its own name. We call it atomic number. So the number of protons in an element is the atomic number, and it's different for each element. That's what makes each element individual. It's the number of protons. It's what makes atoms of different elements different, the number of protons. Neutrons are these orangish colored guys in this picture. They are exactly what they sound like. Neutrons are neutral. Neutral neutrons have no charge. They're located in the nucleus. They have about the same mass as a proton, and they have things to do with how radioactive the nucleus is. So I say it determines mass and stability. So the protons and the neutrons together give us our mass. The electrons are too small to really matter. And the neutrons also contribute to how radioactive the nucleus is, or how radioactive the element is. So stability here refers to radioactivity, not chemical reactivity. Now, the last part of the atom is the electron, and this is the one we're going to spend most of our time looking at because electrons are on the outside of the atom, which means when atoms interact, it's the electrons that can interact, and it's the electrons that are going to determine how they interact. So the electrons determine properties. They have a negative charge, and they're located in a cloud of energy levels around the nucleus. They're very small. They're 1,000, actually almost 1,146 times the mass of a proton. So they're very small. They take up almost no space individually, but because they're zipping around to the whole atom, like you got your nucleus here and the electrons are zipping around in this cloud out here, they're moving around between energy levels and in this cloud, they are what actually takes up the most space of an atom. So if an atom was the size of a football stadium, the electrons would be out near the lights and in near the stands, and a nucleus would be the size of a marble in the middle there. So most of the atom is empty space where the electrons can move. Now, all of this information is actually encoded on the periodic table. I said there's 118 different elements. Well, here's element number 118. What makes it element 118? It has 118 protons. So that number up there is called atomic number. Remember, that's the number of protons. Hydrogen has 1 proton. Helium has 2 protons. Iron has 26 protons. So atoms of each of these different elements have different numbers of protons. Now, there's metals and nonmetals, and we're going to look at those, and there's noble gases, and there's radioactive stuff, and there's man-made stuff, and there's naturally occurring stuff. We're not going to get worried about that yet, but it is kind of interesting to just get a quick intro to the periodic table Atomic number tells us our different elements, and then later we'll see why it's periodic. But it turns out energy levels correspond to rows on the periodic table. So I said electrons can be in energy levels. Every time we start a new row on the periodic table, we also start a new energy level. And the columns actually kind of tell us how many electrons are in the outermost energy level. So everything in column 1 right here has 1 electron in its outer energy level. Everything in column 18, which we'll also learn is called column 8A, has 8 electrons in its outer energy level. So we're going to spend some time looking at some properties of the periodic table and properties of elements. But for now, know your protons, neutrons, and electrons, and where they are in the atom, and how to get the number of protons out of the periodic table. It is worth noting that atoms are neutral, and because atoms are neutral, the number of protons is equal to the number of electrons. So not only does an atom of iron have 26 protons, it will also have 26 electrons.